Hey everybody, it's Mr. Carr again. Today we're going to be looking at 1.2 day 2, which is going to be covering midpoint in distance formula. So let's start with this, a little review. Pythagorean theorem. If you have a right triangle, we have the two sides that are make up that right angle called legs. The third side, the longest side, is the hypotenuse. Okay, and so the relationship in a Pythagorean theorem for a right triangle, according to Pythagorean theorem, is that if I take a leg squared plus the other leg squared, that equals the hypotenuse squared. Okay. Now, last time you might see this where if I call this leg A and this leg B, the hypotenuse C, you'll see it as A squared plus B squared is equal to C squared. The distance formula is actually an application of this. Let me just pick two random points. I don't actually care what their values are. We're finding the length of that, calling it distance D. So let's call this one x1, y1 and x2, y2. Okay, so the idea here is that if I model this length here and that length there, going in the x direction, we can call this x2 minus x1. That's this length here. This length is going to be y2 minus y1. So using our Pythagorean theorem, that means the distance squared is equal to x2 minus x1 squared plus y2 minus y1 squared. But we don't necessarily want to write it this way. If we want a formula, then we want just the distance d. So I'm going to undo this with the square root. So it looks like this. The distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to use either one of these, and we're actually in the next problem, we're going to use both options to find the length of a segment RT here. So let me plot RT, which is at negative 1, 1, and 3, 2, 1, 2, 3, 1, 2, 3, 1, 2. So here's R, here's T. Okay. Oops. Make that better. There we go. And since I got to do this again, let's just go ahead and duplicate that and bring it on over. Close enough. Okay. If I want to apply the Pythagorean theorem, I'm going to turn this segment into a right triangle. So let's zoom in a little bit here. So since it's a right triangle, I just need to find the length of each leg. So my distance D here, this leg is 1, 2, 3, 4. This one is 1, 2, 3. So that means the distance squared is equal to 3 squared plus 4 squared. So the distance squared is equal to 9 plus 16, which is going to give me 25. And then I square root that and I get 5. So the length of our segment here is just 5. When I come over here and to do my distance formula, okay, I got to come back up here a little bit. And right there is good. As you can see, we have our points, so we'll call this x1, y1, and x2, y2. It does not matter which one's which, just want to be consistent. So the distance formula is going to equal to the square root of, we're going to do x2 minus x1, so it'll be minus a negative 1 squared, plus y2 minus y1 squared. So when you subtract negatives, they turn into positives. So this is going to be the square root of 4 squared. This is going to become positive as well, so it's going to be 3 squared. From there, we're going to have the distance is equal to the square root of 16 plus 9, which is the square root of 25, which is 5. Notice this is the same answer either way. It does not matter which method you use what's more comfortable for you. Okay, so one more thing. Oh, another example where we apply our distance formula. So we have 2, 3, 1, 2, 3. Here's R. And then 4, negative 1. 1, 2, 3, 4, negative 1. So the one nice thing about the distance formula is I don't have to graph it. I did right now, but I don't have to. I can go right to this idea. Okay, so I know I can just set it up as D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we got 4 minus 2 is going to give me 2 squared. Negative 1 minus 3 is a negative 4 squared. This is important. If you're going to do distance formula, make sure that this is inside parentheses. You want it to be a negative times a negative here because you're squaring that difference. So that's going to become a positive 4 and a positive 16, which becomes the square root of 20. Now, lots of times we want to know the exact value, so we're going to take the square root of 20 and break it down. That is 4 times 5, which is 2 times 2, and then times 5. So if I want an exact answer, the distance is equal to, whoops, got ahead of myself. Since I have a pair of 2's, that's going to come out to the front of the radical. Try that again. And then I'm going to have square root of 5 that's left over. The approximate, okay, approximate is going to be equal to just plugging in my calculator. So this comes out to about 4.47 when I plug that in. And we can see here, if I were to draw this out, I do have 2 and 4 from my sides of my triangle, which is where this and this come from. Okay, so discovering our midpoint formula. So we have a few examples here. Feel free if you want to pause this and see if you can try it on your own. But I'm just going to run through real quick. So point A is at 0, 4, 2, 3, 4. Point B is at 6, 4, 4, 5, 6. So if I look at this as a horizontal line, I want to find what is in the middle. Okay, so plot the points and then determine the coordinates of the midpoint. Midpoint seems to be right here because I go 1, 2, 3, 1, 2, 3. So that is at the point 3, 4. If I do this one, it's 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So here's C and D. So when I look vertically, okay, if I come down, I can go basically, we go 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4, 5, 6 up. There's my midpoint. And so that happens at -3, -1. Okay, let's try something that's not horizontal or vertical. So we have point E, which is at 2, 2, and then point 8, which is 8, 8. Or sorry, point F. Okay. So this one visually looks kind of like if I were to do this, if I were to go up 1, 2, 3, I think 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. So that means that's the middle point. So if I do that, that is the point 5, 5. Okay, -2, 4, 1, 2, 3, 4. That's G, and then 4, 1, 2, 3, 4, 3, 4, 5, 6. Here's H. A little bit longer, but visually, I should be able to kind of find a good idea of it, which looks like about right here. If I do that, it says 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5. Notice how, based on what I'm doing here, it's gonna be 1, -1. I'm kind of making sure that it's the same distance on both sides. Like that's what we're going to have in the middle. We're basically creating, I'll come back. We're creating scenarios where this is actually congruent to that. That's congruent to that. Okay. So we're creating scenarios where we have these midpoint is right in the middle. So it has to be equal on both sides here. So when I get to this one, -7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Here's point J, 1, 2, 3, 4, and 1 for K. So this one's a little bit different because my midpoint is showing up on like a halfway spot here. So if I do that, let's see here, that is 1, 2, 3, yeah. Looks like, well, wait, is it here? 1, 2, 3, 4, 5. 1 second here. Okay, sorry. I realized that my line is probably just a little bit off because my left side there is not as high as it should be. So let's do that. That looks a little bit better right there. So my midpoint seems to be about right here. Okay, and that's happening at a -1.5 and -1. So I look at this, I can go 1, 2 up, and then 1, 2, 3, 4, 5 and a half there. 1, 2 up, 1, a half, and then 1, 2, 3, 4, 5. So 5.5 in both directions there. So if you are not sure what I'm doing yet with this to get to that spot here, here's our midpoint formula. If we're looking for the midpoint of a segment with these endpoints like this, then I would say my midpoint is equal to, it's going to be the average of each coordinate pair. Okay, so y1 plus y2 divided by 2. So if we take the two x's, add them up, divide by 2, the two y's, add them up, divide by 2, we can see where the midpoint is. That's what's in the middle. That works very well with vertical and horizontal lines like these. Okay. What is in the middle of 0 and 6? Well, 0 plus 6 is 6, divided by 2 is 3. And 4 doesn't matter. 4 stays the same. Same thing with vertical. If I look at 5 and negative 7, 5 plus a negative 7 is a negative 2, divided by 2 is negative 1. So we can always find the middle of two values by taking their average. We add them up, divide by 2. So when I look at 6, I'm going to come back to that one now. This one is a little bit trickier because I couldn't graph it. So that's why we want this formula. So my midpoint is going to equal to, it'll be negative 12 plus a negative 4 divided by 2. And then 25 plus a negative 13 divided by 2. Okay, and that's tough to see a little bit here, but that's supposed to be a negative 13. Okay, negative 13. So if I do negative 12 plus a negative 4, that is a negative 16 over 2. 25 plus a negative 13 is a positive 12 over 2. So that means that I'm going to use that to get my midpoint, which is at negative 8, positive 6. Okay, and that, yep, and these are some for you to try on your own. So that's how we can use our midpoint formula, especially if we're off the graph and it's a little bit harder to see. But bottom line is we have two main ideas today. We're finding the length or distance of a line segment. We can do either Pythagorean theorem or distance formula, both based on the same thing, so it doesn't really matter. And then the other thing is finding our midpoints. So midpoints are like an average of our x's and an average of our y's. So that is it for today for 1.2 day 2. All right, take care, everyone.